moment, I forgot to switch on the light. Okay, so let us assume we have a matrix A as A, B, C, P, Q, R. So what will be A transpose in that case? So make the first row as first column, make the second row as second column. So if this matrix A is of order 2:3, its transpose will be of order 3:2. Later on. So if A is of order 2/3, A transpose is of order 3:2. Similarly, say you have a square matrix A, say ABC, PQR, XYZ. So that means what is A transpose as first row is first column, second row is second column, third row is third column. ABC, PQR, and XYZ. Am I clear? Now, properties of transpose. Properties of transpose. See, matrix A transpose का transpose will regain the matrix A. Am I clear? If you do A transpose, then its transpose, you will get A again. A plus B transpose will be A transpose plus B transpose. A minus B transpose will be A transpose minus B transpose. Number 4, AB transpose will be B transpose A transpose. This is what we call a reversal law of transpose. So if there are more matrices, say A, B, C, D transpose, then it will be D transpose, C transpose, B transpose, and A transpose. All right. Fifth property, say matrix is multiplied by a scalar K, then Ka transpose is K times A transpose. Ka transpose is K times A transpose. And A to the power n transpose is directly A transpose to the power n. Is it okay? So these are some basic properties of transpose. Now after this, anybody having any doubt till this point? Anybody? Well, now there comes two different type of matrices into picture. One is symmetric matrix. One is symmetric matrix. So what is a symmetric matrix? A matrix A is called symmetric if A is equals to A transpose. A matrix A is called symmetric if A equals to A transpose. Now let us assume we have a matrix A as ABC, PQR, XYZ. Now its A transpose will be ABC, PQR, XYZ. So what is A plus A transpose? 2A, B plus B, C plus X. P plus B, 2q, r plus y, x plus c, y plus r, 2z. Now, just a moment. Here we don't have to do this, but we are trying to do A equals to A transpose. So A equals to A transpose. That means if A equals to A transpose, so B has to be equal to P, C has to be equal to X, and Y has to be equal to R. Yes or no? See, this B should be equal to this P, first condition. Then this C should be equal to this X, second condition, and this R should be equal to this Y. This R should be equal to this Y. Now, if you see this thing only in one matrix, that means C equals to X, P equals to B, and R equals to Y. So that means a matrix is symmetric if A equals to A transpose and its conjugate entries will be equal. Means A12 should be equal to A21, A13 should be equal to A31, and A23 should be equals to A32. Understood? A12 is A21, A13 is A31, and A23 is A32. So this is what? A matrix, symmetric matrix. Then there comes skew symmetric matrix. Then there comes skew symmetric matrix. Skew symmetric matrix. Now, what is a skew symmetric matrix? So, a matrix A is called skew symmetric if A plus A transpose is 0. A matrix A is called skew symmetric if A plus A transpose is 0. Now say you have A as ABC, PQR, XYZ, and A transpose is ABC, PQR, XYZ. Now if I add them, A plus A transpose, it will be what? 2A. B plus P, C plus X. B plus P, 2Q, R plus Y. C plus X, Y plus R, 2Z. Fine. So if you make it 0, that means A has to be 0, Q has to be 0, and Z has to be 0. First of all, though, this is the criteria. Another thing, B plus P should be 0, C plus X should be 0, and R plus Y should be 0. Means B equals to minus P, C equal to minus X, and R equals to minus Y. Now see, C plus X 0. Then B plus P 0. And then R plus Y 0. So what is happening? Sum of conjugate entries is 0 and diagonal entries are necessarily 0. So if the matrix A is A11, A12, A13, A21, A22, A23, A31, A32, A33. So if A is skew symmetric, then what will happen? AI should be 0. AI means diagonal entries. Diagonal entries should be 0. Abhishek, understanding? And Aij plus Aji should also be 0. Second condition. Means what? Sum of conjugate entries should be 0. Sum of conjugate entries should be 0. Correct, everyone? So this is what we call skew symmetric matrix. So symmetric matrix, again I repeat, if their transpose is equal to their self, symmetric matrices, if their transpose is equal to their self, skew symmetric matrix, if their transpose is equal to negative of them. So in symmetric matrix, there is no condition on diagonals, but conjugate entry should be same. In skew symmetric matrix, diagonal should be 0 and sum of conjugate entries should also be 0. Fair enough? Guys, please speak up. Is it okay? Is it okay? Now, one thing, A is 230 302 020. Can anybody tell me what kind of matrix it is? It is symmetric, it is skew symmetric, or it is none of symmetric or skew symmetric? Yes, quickly.
Symmetric.
Symmetric matrix. Very good. This is a symmetric matrix. Now say matrix is, just a moment. Very good. Now say a matrix is, just a moment. Zero, 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 2 minus 2, 0, 0, 0, 0. Okay, what kind of matrix is it? Yes, what kind of matrix is this?
Skew symmetric.
Skew symmetric matrix. Very good. Diagonal entries are 0. Sum of conjugate entries is? Sum of conjugate entries is also 0. So this is a skew symmetric matrix. Skew symmetric matrix. Correct? Now, tell me one thing. Is there any matrix which is considered as symmetric as well as skew symmetric? Null matrix. Null square matrix is considered as symmetric as well as skew symmetric matrix because it has all the properties which a symmetric matrix require as well as all the properties which a skew symmetric matrix require? So null square matrix is the only matrix which is considered as symmetric as well as skew symmetric. Another very important point, every square matrix can be expressed as the sum of a symmetric as well as skew symmetric matrix. So every square matrix, like there is a matrix A, it can be represented as A plus A by 2. Then you can write it A plus A transpose plus A minus A transpose by 2. See the right side. Isn't it A only? Tell me. Whatever you see in the right sides, A transpose will cancel out. You get 2A by 2, which is A only. So I can write A in this manner. Now this will be what? This will be symmetric part of A, and this will be skew symmetric part of A. Symmetric part of A and skew symmetric part of A. We can show it also. Say, let X is A plus A transpose by 2. Now, if I do X transpose will be what? A plus A transpose by 2 transpose of this. Now, I just taught you a property Ka transpose is K times A transpose. So, take this 1 by 2 outside. It is A plus A transpose transpose. Then I taught you that A plus B transpose is A transpose plus B transpose. That means this is half of, it will become A transpose plus A transpose ka transpose. Then there was a property A transpose transpose is A only. That is half of A transpose plus A. Then there is a property that A plus B equals to B plus A. Means matrix addition is commutative. That is half of A plus A transpose, and that is equals to X. So if X transpose is equals to X, means X is symmetric. Have a look at it, absorb it. And once you absorb it, show that A minus A transpose by 2 is skew symmetric. Show this one. Anybody? Harshini, understood? Chandan? Vinay, you got it? Akshay? Now, say you want to show A minus A transpose by 2 is skew symmetric. Let us assume Y is A minus A transpose by 2. Then Y transpose is what? A minus A transpose by 2 transpose of this. half came outside, it is A transpose minus A transpose transpose. That is half of A transpose minus A. Take minus common. So it became half of A minus A transpose. So it is minus Y. Since Y transpose is minus Y, so we say Y is skew symmetric matrix. Y is skew symmetric matrix. Understood? Okay, now let's write down a question. Express the matrix A equals to minus 2, 4, 1, 2, 3, 1, 3 minus 2 minus 1 as the sum of a symmetric matrix P and skew symmetric matrix Q. Express the matrix A as the sum of a symmetric matrix P and skew symmetric matrix Q. Hence, क्या होगा? वो मुझे भी नहीं मिला था. Hence, find product PQ. Yes, give it a try quickly. Those who are getting it, tell me what is P and Q, and finally what is PQ. Quickly give it a try. Now see, what is P? P will be A plus A transpose by 2. That is half of A is minus 2, 4, 1, 2, 3, 1, 3 minus 2 minus 1. A transpose is minus 2, 4, 1, 2, 3, 1, 3 minus 2 minus 1. This is going to be your P. That is half of minus 4, 6, 4, 6, 6 minus 1, 4 minus 1 minus 2. And then if you do half of it, so your P is going to be, take 1 by 2 inside, minus 2, 3, 2, 3, 3 minus 1 by 2, 2 minus 1 by 2 minus 1. Now see, Q I will be doing directly. That is half of, now it is A minus A transpose. So that would be half of determinant matrix 0, 4 minus 2, 2, 1 minus 3 minus 2, 2 minus 4 minus 2, 3 minus 3 0, 1 plus 2 it will become 3, 3 minus 1 2, minus 3 and this will also become 0. So it will be 0, 1, minus 1, minus 1, 0, 3 by 2, 1, minus 3 by 2, 0. So these are your P and Q. All right. Now PQ though you can calculate, it is just a product. All right. Anybody who can finally help me with PQ, what do you get? Quickly tell me. Anybody? Yes, Rama, Abhishek, Chandan, anyone? Tell me what is PQ? Anybody? All right. I'm also not going to calculate it and do it on your own later. Now see, there are certain kind of questions which are important as well as thought-provoking also. The question is, I'm going to make a table. So we will fill that table thoroughly. Say this is the case. A is symmetric. B is skew symmetric. Here, A and B both symmetric, and here A and B both skew symmetric. Now you are going to tell me about the matrices. In these kind of situations, AB minus BA, AB plus BA, A to the power 4, B to the power 25, minus B to the power 25, A to the power 4. And finally, A to the power 25 plus B to the power 25. So what do you have to say about these cases, that under these circumstances, what will be these four? Under these circumstances, what will be these four? And under these circumstances, what will be these four? All right. See, one or two part I'll do for you. First of all, I'll do, say I name it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Say I'll do first part for you. First part is asymmetric and B skew symmetric. So asymmetric means A transpose is equals to A, And B skew symmetric means B transpose is minus B. A transpose is A and B transpose is minus B. Now let you have a matrix X as AB minus BA. So what will be X transpose? X transpose is AB minus BA transpose. That is AB transpose minus BA transpose. Am I correct? That is B transpose A transpose minus A transpose B transpose. Now B transpose is minus B, A transpose is A. Here A transpose is A, B transpose minus B, so it will become plus sign. So it came out to be AB minus BA. And this is what where you have started with. So this is also equals to X. So what did you get? X transpose is X. That means X is symmetric. So this result came as symmetric matrix. Have a look. From this step to this step, I applied reversal law. If you have understood, just give me a note in the chat box or raise your thumb. Very good. How about others? Everybody please participate and contribute. Yes, yes, quickly. Now, if you have got it, proceed for other parts.
Sir, fourth one is skew symmetric, sir.
Second one is skew symmetric. Okay. And
Fourth,
if
fourth one, sir. Fourth.
sorry, Rama, speak loudly.
Fourth one, sir. Fourth one.
Fourth one is
Skew symmetric, sir.
very good. This will come out to be skew symmetric. Very good. Others also please contribute. See, one more part I'll do. I'll do sixth part. A and B both skew symmetric. So sixth part is A and B both skew symmetric. Means A transpose is minus A and B transpose is minus B. Now say they're asking for let Y equals to AB plus BA. So what is Y transpose? Y transpose is AB plus BA transpose. that is AB transpose plus AB transpose plus BA transpose, yes. Now we'll apply reversal law of transpose. So B transpose A transpose plus A transpose B transpose. Now A transpose is minus A, B transpose is minus B. So it is minus BA. So it will become plus and plus of AB. Or matrix addition is commutative. It will become AB plus BA, which is Y. So Y transpose came Y. That means Y is symmetric. So this one is also symmetric. All right. Now, okay. Now I'll do seventh part. A to the power 4, B to the power 25 minus B to the power 25, A to the power 4. I'll seventh means A symmetric, B skew symmetric. See, seventh part is A symmetric and B skew symmetric. That means A transpose is A, B transpose is minus B. Now let us assume we have a matrix A4, B25. So A to the power 4, B to the power 25 minus B to the power 25, A to the power 4. So what is X transpose? X transpose will be A to the power 4, B to the power 25 minus B to the power 25, A to the power 4 transpose. So A to the power 4, B to the power 25 transpose minus B to the power 25, A to the power 4 transpose. That is, now we will apply the reversal law. Reversal law will make it B transpose to the power 25, A transpose to the power 4 minus A to the power 4. A transpose to the power 4 and B transpose to the power 25. Now B transpose is minus B, and since the power is odd, this minus will come out. Yes, so it will become minus of BA, B25, A4, and it will become plus A4, B25, because B transpose is minus B. So it finally comes out to be A to the power 4, B to the power 25, minus B to the power 25, A to the power 4, which is actually X again. So that means X is symmetric. Whatever I am doing today is coming symmetric only. So this came symmetric. Now I'll do A25, B25. I'll do 12th. 12th is very easy as such. A and B both skew symmetric. That means A transpose is minus A, B transpose is minus B. Now see, there is a matrix H as A25 plus B25. A to the power 25 plus B to the power 25. So H transpose is what? A to the power 25 plus B to the power 25 transpose. That is A to the power 25 transpose plus B to the power 25 transpose. You remember I taught you a property, A to the power n transpose is A transpose to the power n. So it will become A transpose power 25. B transpose power 25. A transpose is minus A and B transpose is minus B. So minus a to the power 25 minus b to the power 25. So minus common, it will be a to the power 25 plus b to the power 25, that is minus h. So finally one matrix also came as skew symmetric. So h is skew symmetric. So in this case, this 12th is skew symmetric. All right. Now I give you 5 minutes. Quickly tell me which is symmetric, which is skew symmetric for rest of the parts.
Sir, fifth one symmetric.
Which one?
Fifth one, sir, fifth one.
Fifth one is
Symmetric, sir.
symmetric. Very good. Other parts?
11th one too symmetric, sir.
11th is
Symmetric.
symmetric. See, 12th will be neither symmetric nor skew symmetric. Because when you take transpose, it will come out to be as a to the power 25 minus b to the power 25, which is neither equal to x nor equals to y, minus x. Other spot also, 4 left. Quickly, second, third, 8, 9. Please respond. Yes, quickly.
Second one skew symmetric, sir.
Second one,
Skew symmetric, sir.
skew symmetric. Very good. Yes.
Third one also skew symmetric, sir.
Sorry.
Third one, sir.
Third one is
Skew symmetric, sir.
skew symmetric. I doubt. I think third one should be symmetric. A and B both skew symmetric. See, AB minus BA. So it will be, yes, correct. Both are skew symmetric. So it will be BA minus AB. Yes, this will be skew symmetric. Only 8th and 9th left. Quickly respond.
Sir, 8th one skew symmetries.
8th is
8th one skew symmetries, sir.
both symmetric. So 8th will be skew symmetric.
Yes.
And 9th will be, 9th will also be skew symmetric. A and B both symmetric. Symmetric. 9th will be minus will become 9th will be symmetric. All right. See, you can take a screenshot of this page. Make sure you do each and every part on your own. And this first and second, 1, 2, 3, 4, 5, 6, they are very relevant with respect to board point of view. They came in boards also. This 7 to 12th part, if you see, This kind of question are very widely asked in JEE Mains, JEE Advanced. The 7th and 7 to 12th, they both were asked in a paper of JEE Advanced. Once upon a time, like not too long, I think 3 to 4 years back. All right. So now let's wind it up quickly. So what we have done today is what is a transpose? Transpose is what? When we interchange the rows and columns of a matrix. Then we have studied the properties of transpose, in which I guess almost all the properties I have used in questions today. Then symmetric matrix. When do we call a matrix symmetric? When conjugate entries are equal. Then skew symmetric matrix. When do we call a matrix skew symmetric? When diagonal entries are 0 and sum of the conjugate entries is 0. So sum of the conjugate entries is 0 and diagonal is also 0. In case of symmetric matrix, transpose of the matrix is equal to matrix itself. In case of skew symmetric matrix, transpose of the matrix plus matrix goes 0. Then null matrix is the only matrix which is considered as symmetric as well as skew symmetric. Every square matrix can be expressed as the sum of a symmetric and a skew symmetric matrix. That is A plus A transpose by 2 plus A minus A transpose by 2. Then we have proved them. Then we have done a question where we were supposed to express a matrix as the sum of a symmetric and a skew symmetric matrix. We have done that. Then we have made this table where we understood if we are given with 2 or 3 matrices as symmetric or skew symmetric, how to find their combinations as symmetric or skew symmetric. Here we have done AB minus BA, AB plus BA, and so on. All right. I think today we have gone through so many good things. You understood all of them. And that would be all from my side for today. All right. So now I would just like to ask you for a small feedback about this session, then we will end.